Okay, y'all, so we're gonna kind of shift gears out of the systems of equation thing and go back to just normal equations. And I was kind of trying to decide if I really wanted to do this virtually, or if I thought maybe we should wait and try to do this when we're face to face. But I think we probably can handle what we need to learn from this virtually. But if you have questions as we're working through this, you can always jump on the Google Meet and ask, that kind of thing. But basically, what I want you to learn from this first lesson is we're going to look at the form of an equation, a linear equation. And so there are two different forms of that. Last year, we focused strictly on what's called slope-intercept form, or we know it better maybe as y equals mx plus b. So you need to know when we refer to slope-intercept form, that's what we're talking about. So slope-intercept form is y equals mx plus b. We already know that x and y are input and output. You need to make sure you know that the m part of that equation is the slope, and the b is the vertical intercept or the y-intercept. So when we look at that equation, whatever's in the m position is the rise over run or the slope or the rate of change, whatever you want to call it. What's in the b position is where it crosses the y-axis or its initial value or its starting point. So that's called slope-intercept form, but it is possible to rearrange a slope-intercept form equation into a different form. So we have another particular format that is called standard form. So standard form is when you have your x and your y term on the same side. And more specifically than that, so this is called standard form. So we have x and y on the same side, ax plus by equals c. A, B, and C are constants, but they also have to be whole numbers, or A has to be a whole number. No, they all have to be whole numbers, I'm sorry, and A has to be positive to officially be in standard form. Now, we're not going to do a whole lot of focus on that idea because we're really not going to use an equation in standard form. If we're given an equation in standard form, we're really pretty much just going to rearrange it into slope-intercept form. I'm not going to ask you to change it from slope-intercept back to standard. I might ask you to change from standard back into slope-intercept. The changing something into standard form is just more complicated than what we have to deal with in a basic Algebra 1 course, so we're not going to worry too much about that. So in slope-intercept form, the m and the b actually represent things that are important to us in the function. In standard form, the a, the b, and the c are just constants. They don't have any real meaning for us as far as what the graph is going to look like of this. So if we were going to try to graph the equation, we would have to have the equation in slope-intercept form to be able to graph it, because slope-intercept form tells me where it crosses the y, it tells me that intercept, and it tells me how much it's growing by every time. Now, fun thing is, Desmos will graph them in whatever form they're in. So it doesn't really matter for us which form it's in to be able to graph it, but we want to be able to pick out the things that are important from it too. So let's look at an example of a linear equation that is currently in standard form. So this one's in standard form, 3x minus 5y equals 30. We're going to rearrange that into slope-intercept form. So to do that, we do have to do this by hand. There's no way to make Desmos rearrange the equation for us. It would be cool if it did, but it doesn't. So here's what we deal with here. We take our original, 3x minus 5y equals 30. And we're basically going to rearrange this thing so that the y is the only thing left on the left side. So I'm going to start out, and this is going to feel weird because we're so used to moving the x's to the left. But in this situation, all I want to have left on the left side is this y right here. So I'm going to have to be able to move everything else to the other side. So we're going to start out by moving the x to the other side. We can subtract 3x. 3x minus 3x will cancel. So we'll subtract it over here. And then all we're left with on this side is this negative 5 that's attached to the y. So at that point, I'm going to bring it all down so we can kind of see it. Now, we can't combine 30 and the minus 3x because the 3x has an x with it and the 30 does not. So we're just going to write that as, it doesn't really matter. I'm going to leave it like that, actually. I was going to rearrange it, but I changed my mind. Like that. And so all we have left to do at this point is get rid of that negative 5. And we always do that by dividing by negative 5. Now, here's what you want to be careful of. And I realize I wrote gigantic. Hopefully you didn't. So the y is left on this side. On this side, both pieces have to be divided by the -5. So 30 divided by -5 is -6. -3 divided by -5 becomes positive 3 over 5x, or 3/5 x. Now, technically, that's not exactly slope-intercept form, because in slope-intercept form, the x term comes before the b term. So we really should rearrange that into 3/5 x minus 6. So the 3/5 is still positive, the 6 is still negative. And this is technically slope-intercept form. So I've just rearranged that, solved it for y. Now they ask us, once we've done that, to identify the slope. Well, we know in slope-intercept form, the slope is the one in the m position. Y equals mx plus b. So the one in the m position of this is 3 over 5. By the way, it would be absolutely okay to put 0.6 if you did that. But our slope is 3/5. The vertical intercept, or the y-intercept, is the b. So for this, -6. Now, the horizontal intercept is a little bit tricky. Horizontal intercept is the value of the x when the y is equal to 0. You have a couple of options on how you could find the horizontal intercept. By the way, this should be 0, -6. And we're going to find the horizontal intercept. You could graph it, and that's probably the quickest way to do this, is just to graph it in Desmos. So I'm going to grab Desmos real quick. By the way, if you have not downloaded the Desmos app on your phone, it might be super useful for you to have that. So y equals 3/5 x plus 6, or minus 6. Or you could type in 3x minus 5y equals 30. I think I'm going to do that just because it's faster for me than typing fractions. Okay, there it is. And my horizontal intercept is at 10. You'll see how it crosses the horizontal axis at 10. So my horizontal intercept is 10, 0. If I want to make sure I didn't mess something up when I rearrange my equation, I can go double check my vertical intercept. It is at -6, so we're good. So that's how we're going to rearrange equations from standard to slope intercept. Always move the x term to the right side, then divide by whatever's attached to the y. You might want, it might be helpful to make yourself a note of that. If you think you'll forget, or you think you're not comfortable with what the steps are, jot them down. Step 1, move the x. Step 2, I don't know why let me try this again. It's not working out very well for me. Step 1, move the x to the right. Step 2, divide by the number with the y. That's always going to be your steps for that if you're moving from standard to slope intercept. All right. Let's keep going. So now they ask us to graph a function that's given to us. And so if they ask you to draw an accurate graph, they ask us to give this in slope-intercept form also. I'm actually going to let us graph it first and then put it in slope-intercept form, and then we'll kind of talk through what's an easier option for you. But if you were asked to graph something that's in standard form, easiest thing to do is to grab Desmos because it will graph it for us. There's no reason to reinvent the wheel if it's already been, a tool has been given to us to do it. So 3x plus 2y equals 16. So just like when we were graphing systems, when you are asked to create a graph, you need 2 points. I would say to choose your intercepts if you can, because that's just going to be easier for you to plot points on. So if you notice in this crosses the y-axis at 8 and the x-axis not at a pretty spot. So I'm not going to be able to use that intercept right there. But I do cross the y up here at 8, so that's useful. This is not a perfect stop sign points. We can't use that one. So remember, when you don't have a stop sign point, you travel down your line till you find one that is. Like this one. This is at a nice intersection right here. So I can graph the point 2, 5, and that'll be another point on my line. So I'm going to grab this and move it. And then I'm going to plot some points here. So I had one at 8 is what I wanted to start with. I could number this. I'm not going to. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And then we said 2, 5. So 1, 2, and then 1, 2, 3, 4, 5. So I'm going to put a dot there. And then if you wanted more than just 2 points, like you could grab your Desmos again and find another. Have another one down here at 4, 2 if I wanted to put that one on there. 2 points is enough, especially if you're doing this on the computer, because it's going to click into place for you anyway. But if you are doing it by hand, like on a sheet of graph paper, you might want a couple more just to give you a super straight deal. I think I have a line. Okay, let's try this. Yeah. And then you would draw your line through all of your points like that. And it should have arrows on both ends. This software doesn't allow me to do that. So that is what our equation of our line looks like. Now, we could write the equation, or what the line itself looks like from the graph. We can write our equation in slope-intercept form if we can figure out our slope and our y-intercept. Well, our y-intercept is easy. I can count that. 1, 2, 3, 4, 5, 6, 7, 8. So I know the b part of my y equals mx plus b is positive 8. Now I have to figure out the m. The m is your slope. And if you remember from last year, to find slope from a graph, you can rise and run. Now you might notice that this one is not rising, it's falling. But same concept. So we can start here and we can fall and run. We fall 3 and run 2. So our slope is 3 over 2. And that's going to be negative because it's falling. So the slope is negative 3 over 2. The vertical intercept was 0, 8. Now our horizontal intercept was not a nice pretty number that we could graph, but we should still be able to figure out what it is from Desmos. I might have to type that back in again. 3x plus 2y equals 16. Okay, let's look and see. So it's 5.3 repeating, comma 0. Oh, wrong button, y'all. Ignore that. So my horizontal intercept, the place where it touches the x-axis, is 5.3 repeating 0. And then if they ask for some additional points on the line, you could give any of those points that we already graphed over here. So we have those. We also found out that 2, 5 was on the line. We also found out that 4, 2 was on the line. So really any nice, pretty stop sign points would be good to put if they ask you for additional points. Oh, where'd my line go? Let's put it back. Oh, now it's red. Oh, well. All right. That's how we're going to graph those lines. We're going to pull 2 points from Desmos, and then we will graph them like that. We can find our intercepts by looking at Desmos and clicking on both the points on the axes. We can find our slope using rise over run. Now, you also could have just taken this function to get the slope intercept form. I'm going to show you this. You don't have to write this down, but if you like this option, you can. And you can subtract your x term. So subtract 3x. and then divide everything by 2. And you would get 8 minus 3 over 2x, which is basically the same thing, negative 3 over 2x, positive 8. So same idea, but that was done by rearranging the equation to get the slope-intercept form, as opposed to using Desmos to graph the line and then doing the slope-intercept form. Either one is really okay. Over 2. All right, so if they ask you to graph this one, see if you can graph this using the information Desmos gives you. So pause the video, attempt to graph it, and then see if you can get a slope-intercept form of the equation. If you're not sure how to write the slope-intercept form of the equation using the line that you get and finding the slope and the y-intercept, then try to rearrange this into slope-intercept form. Either way, I'd like you to try to get a y equals mx plus b equation and an accurate graph. Once you've done both of those things, come back to the video and we'll talk through some of the rest of this with the slope and the intercepts. But I would like you to attempt to graph it and get the equation rearranged yourself if possible. So pause it and come back when you're done. Okay, so for this one, hopefully when you rearranged it, either you rearranged it or you graphed it, either one. You subtracted 4x perhaps. And then the negative y is really a negative 1y. So you divide by negative 1. So your equation here was y equals negative 4x divided by negative 1 was positive 4x. 7 divided by negative 1 was negative 7. So you would have had a dot here. Maybe like that. Or you may have, more likely than not, you got Desmos to do this for you instead, which is absolutely fine. I did mine with using the slope and the y-intercept to graph it like we did last year. But if you did it in Desmos, which is what I would expect you to do because that's what I told you to do. And we did 4x minus y equals 7. 4x minus y equals 7, like that. Then you'll notice that it does cross at 7 down here, and you put that point. The x, hang on, so it crosses at 7. The x-intercept, or the horizontal intercept, is not very easy to graph, so we wouldn't want to use that point. But we could use this one, and then we can use this one, which is negative 3, 1. We could use this one, that is 2, 1. So there are lots of different things we could use. Oops, wrong button. So either way, we get that. We get our graph put into place. Our slope, even if you did this with it and didn't rearrange it there, hopefully you could still figure out your slope by rising and running. So if you had done that and you had this point and you went 1, 2, 3, 4 over 1. 4 over 1 is a slope of 4, which is exactly what we have up here. And the y-intercept is negative 7 because that's where it crossed the y-axis. So our slope is 4. Vertical intercept is 0, negative 7. Our horizontal intercept is not a nice, pretty number, so we're going to pull that straight off of our graph in Desmos. And if I touch that point, maybe not. It is 1.75, comma 0. So I can write that in 1.75, comma 0. And then some additional points on the line would be any of those stop sign points that we put down. So like this one, 1, negative 3. Positive 1, negative 3. Or that other one that we had at 2, 1. So 2, 1. And there are lots of other points we could use, but those satisfy what we need at this particular spot. Okay, and that walks us through how to rearrange and graph equations in standard or slope-intercept form. Okay, so this section asks us to look at writing our own equation, either in standard form or possibly in slope-intercept form. I think most of these are going to be in standard form because it says general form or standard form. So what you typically see in equations that you're having to write in a particular form is that you have two different variables, and you can use x and y, but you don't have to. You can use different letters to help you remember what things are. We did some equations in this general form or standard form when we did systems of equations. We just didn't call it standard form because that wasn't a part of that particular lesson. It was just, can you create the system? So when we look at these, we have to think about what numbers go with what particular variable. So we make sure we have the right number attached to the correct variable. And then we also want to be able to look for a total because we know the total is going to be on the right side of the equal sign. So look at this example. It says movie tickets cost $7 for adults and $5.50 for children. And then it tells us a total of $668 was collected for the Saturday matinee. And they want us to write an equation that represents the total amount of money collected. So an equation has an equal sign. We know the total amount of money collected was $668. So our equation has to equal $668. Now that $668 was a collection of money that was paid for adult movie tickets and money that was paid for children's movie tickets. We don't know how many of either they sold. So I can create an equation from this with the idea that every adult ticket sold was $7 and every child's ticket that was sold was $5.50. So that means 7 per adult plus $5.50 per child's ticket had to equal $668 total. So if we know this, if we can create this equation, we can use this equation to figure out, well, if a certain number of one was sold, how many of the other? Or what if we sold this many of one, how many of the other would we be able to sell? So you can really kind of evaluate it for any number of things. But if they give you a specific thing they want you to evaluate, like part B does, sorry about that, y'all, there's something on my screen here. I was trying to get it off, but it did something weird. Then we can evaluate it for whatever value they ask us to. So in B, it says if 42 adult tickets were sold, then how many children were there? So we can substitute 42 in place of the A in this function, because the A in this function represented adult tickets, and we can solve for C. Or, I'll show you how that works, and then I'm going to show you an alternate method for doing that. 7 times 42 plus 550C equals 668. And we can solve that. We can do 7 times 42 and get 294. And then to solve that, we would subtract the 294. So it's just solving a basic equation now. 668 minus 294 is 374. And this side is still 550C. And so we divide by 550. And I don't really have space down there to write this. So C would equal 68 tickets. So you can substitute directly into there. I will give you an alternate option. Okay, so I'm going to grab Desmos here. And we're going to look at how we can use Desmos to help us to figure out that value of 68 without having to solve the equation with it substituted in. Although we can do that. But another option that you have is if you would type in 7x, I'm going to have to use x and y, plus 5.50y equals 668. So at this point, we know x is adults and y is children, because we had that in our original function. And we know that there were 42 adult tickets, which means we know that x is equal to 42. So I've created now the original function and what I know one of the variables to be. And so if I scroll out, zoom out, I can see my line where x is 42 right here. So I have this line. That line exists where x is 42. That's just telling us that that's the value of x. And then we're going to go up here and find the place where they intersect. Ooh, that was not intentional. There we go. And so you can see when the x is 42, the red line is at 68, or the y part of that is at 68. So exactly the same value that we got when we solved for the number of children's tickets. So any point on this line represents something that would satisfy that equation. If I were to have wanted to know, let's say, how many children's tickets would be sold if the number of adult tickets was, hang on, I got to get this back straight because I can't read it if it's not. Let's say I want to know how many children's tickets would be sold if the number of adult tickets was, I don't know, 56 maybe. Yeah, that's good. So I could look at 56, and there's the line right there at 50. So any point on here would work, and if I needed to evaluate it at any other point, I can change it to whatever I need the x to be. So Desmos can allow you to look at that without having to spend the time solving it. Either way works. If you're good at solving equations and you like it, do it. If you're not real comfortable solving equations, then graph it and find that particular point on the graph itself. If you think you can, try to set up the equation for this one on your own, based on kind of what we just did in the last one. If you don't think you're quite ready for that, you can keep watching the video and I will work it with you. If you are ready, or you think you want to try it, pause it and see if you get the correct equation. And then we'll kind of talk through part B of this. So it says, at a concession stand, 2 hot dogs and 3 sodas cost $12. So they want us to let H be the price of a hot dog and S be the price of a soda. And they want us to write an equation in general form or in standard form for this situation. So if we know 2 hot dogs and 3 sodas, y'all know how I feel about S's in there, but anyway, equal $12. That's my equation in general form. That's an S, maybe. And so then it says, if sodas cost $1.50 each, how much is each hot dog? Well, I can do this. 2H, plus 3 times sodas are $1.50 equals 12. And I can solve that equation. Or I can use Desmos. And I can type in my equation. 2x plus 3y equals 12. Oops, just kidding. And then I can type in the fact that I know sodas, which are my y's, equal $1.50. Now, if I do that, and I find the point of intersection, 375, 1.5, which means the x, or what's the h for this, has to be 375. So hot dogs are $3.75 each if sodas are $1.50 each. So you can use Desmos for that. Just find the point of intersection after you input your original equation and what you know. Or you could solve this just the traditional way. Let me move this, maybe. Won't let me move. Oh, yeah, well, good. If I solve this the traditional way, I would be 2h plus 450 equals 12, because I multiplied that, and then I'd subtract 450 from both sides. And then divide that by 2. And that's where my 375 comes from. But again, if you're not comfortable having to sub into the equation and then solve like that, you can always put both parts into Desmos and then find their point of intersection like when we did systems. Okay, And that wraps up applications of linear equations.